Hi, I am Shahmi,
I am Akmal.
and I'll be presenting the article critique done on the secondary review paper Advanced Technologies for Plastic Waste Recycling by Alabi et al. The core objective of the paper is to compare and evaluate traditional mechanical recycling against modern chemical, biological, and AI-driven sorting routes regarding sustainability, economics, and circular economy integration. The methods used are systematic literature synthesis and multi-criteria comparative analysis. The key finding here is that there is no single universal way to tackle effective plastic waste management, but instead requires matching specific waste streams with targeted hybrid processing pathways operating under supportive policy frameworks. To discuss on the clarity of research questions, it is without a doubt that the article has a clear research question, which is how mechanical, chemical, biological, and AI-driven technologies integrate to establish a net carbon negative and economically viable circular economy. There is a well-defined scope that creates a direct comparative framework between old traditional methods used and new emerging innovations targeted to its severe ecological threats. Now, the methodologies used are moderately flawed with some analytical limitations. Firstly, there is an unstandardized baseline where the article used pooled secondary data across studies without having an solid normalizing processing boundaries. Then secondly, it has inconsistent metrics. The life cycle assessments or LCA and techno-economic analysis TEA were compared across unequal scopes, which creates a unclear or inaccurate interpretation of the data used. Lastly, it has mismatched readiness level. Early lab stage concepts at low technology readiness levels or TRL were directly compared against industrial scale operations that has TRL of 8 to 9 without applying statistical normalizations. To continue, we have the validity of results and data interpretation. Now, although the methodologies used are flawed, the qualitative conclusions are logically valid, with clear trade-offs of each of the mentioned methods of mechanical, chemical, and biological methods that shows that there is no single way to tackle effective plastic waste management.
The big issue here is that because the authors didn't use statistical controls to smooth out data differences, it's a stretch to assume these lab results will work out the same way in real-world factories. Looking at the limitations, the biggest gap is how the authors compared early small-scale lab tests directly against massive industrial plants. To actually bridge that gap, future studies need to use standardized, scale-ready metrics, things like measuring the exact energy used per kilograms processed or production's yield per hour. That's the only way we can accurately predict how these technologies will perform when scaled up from a benchtop to an actual factory floor. Despite those limitations, the findings are still super practical. For industry leaders, the paper shows that the real future lies in hybrid systems, like using AI to sort plastic first and then sending specific waste to targeted chemical or biological treatment. For policymakers, it highlights that because modern recycling requires so much energy and startup capital, we need targeted financial incentives, carbon taxes, and upgraded infrastructures to make them financially viable. To wrap things up, Alabi and colleagues rightly shows that solving the plastic crisis requires a smart combination of technologies working together. However, to turn these insights into real-world action, future research must fix key methodological gaps by using standardized metrics and long-term pilot data. That is how we will move from academic theory to profitable, eco-friendly recycling networks. That's all from us. Thank you very much.